So what I'd like you to do in the time before class is go ahead to modules and download this data set called Cars, and then import that into StatCrunch, and that way we'll be ready when class starts. Start the roll off with you, so after class starts, let's go ahead and Well, it's looking like time to get started. So before we begin, any questions that you might have about the homework, my stat lab, anything like that? Everyone's pretty good. If you do ever run into any issues, and you would not be the first, please feel free to contact me. Okay. Some of the things we can do really quick, but even if I can't, I have a really good hotline number for the Pearson Help. They're very thorough. They're very helpful. Okay. So what I want to do is I want to start and talk a little bit about one issue that we didn't discuss last time to kind of wrap up chapter 1, which is the different ways that we can collect data. And so this is important from a lot of different perspectives. The one thing is it's important to understand what we can get from different types of studies, because this is really one genuine area where there's a lot of confusion. Please. Nope, it did. Okay. So the first type of study is what we call observational study. One of the cool things about statistics is you'll find out that words sound like what they mean. So an observational study is where you just observe and write down what you see. In other words, we're not interacting with the people that we're studying. We're not intervening. We're not giving them a treatment, a drug, anything like that. One of the bad things about this is, though, that we can only get relationships between things. And the relationships we get are non-causal. In other words, from an observational study alone, we can't show that something causes something else. Okay? So that's kind of important to understand. There are different types of observational studies, okay? And this can be a little bit confusing. The way I think of it is I think of observational studies as kind of like this. I think of time as being along an axis, okay? And we have a population at some time. We could talk about all the Embry-Riddle students right now, okay? So this is our population. And what we can do, first of all, is we can take a sample from that population at one time. And that's what we call a cross-sectional study. Okay, so if I just take a little snippet, a little sample of my population now, this would be a cross-sectional study. In other words, it's like I'm taking a cross-section of the population in time, right? And that's very often what you see. But sometimes we want time to be, another variable, so to speak. So there's two different ways that time can come into study. The first thing I can do is I can look at a particular sample from the population, and I can just fix on that one group of people and then follow them over time, okay? But it's the same group I'm looking at, okay? So I go ahead, I choose a sample, and I follow that sample over time, okay? So you think of it kind of like this, right? I'm just kind of following these people over time. And then I may want to see what happens to them at some later time, okay? We call this group, sometimes you'll hear the word cohort. So cohort is just kind of a group of people that have something in common. what they have in common here is that I'm studying them over time. Usually it's human subjects, and usually it's for a short period of time. So we don't study cohorts, especially like for medical studies. There are some exceptions, some really famous exceptions, but for the most part, longitudinal studies are kind of short in time. But very often we want to study what's called a time series, especially in finance. So when we're studying a time series, we're generally not studying a person. We're usually studying some sort of estimator. So when we're looking at a time series, for example, we're looking at, say, like an average. We're not looking at a sample. We're looking at something computed from a sample. And we want to follow this average over time, and we want to follow it at regularly spaced intervals. Okay. And that's really a time series. So time series, really we're not looking at samples. We're looking at some sort of aggregate measure from a sample. We're following that. So for example, very, very common time series when you're looking at finance are stocks. Okay, you may sometimes they're individuals. Okay, sometimes it's a stock price, but very often we're looking at the Dow Jones average and stuff like that over time. Okay, and so kind of the idea is that you're getting two different things from these types of studies. When you're doing time series, you're kind of looking for correlations. You're looking to see, for example, is there some sort of trend? So if I want to test, for example, your knowledge of business statistics, I might tell you something, and then I might see how long that memory lasts, okay? So usually with time series, we'll kind of see how long something persists. And that's why we have to look over longer time periods. If you have any questions, sometimes it gets a little, especially when you start off, it's a little hard figuring out the boundary between longitudinal and time series. Just ask me, but usually it's pretty clear if you kind of use that as a rule of thumb. Okay? And so on this other page, I just basically, put what I wrote there, okay? So surveys, everyone has to do them. Sometimes they're a pain, okay? So we all know what they are, okay? Course evaluations. At the end of this class, you're going to have a survey, right, where we ask your response on various sorts of questions. Surveys are great, but you always have to be aware of the fact that there's a lot of sources of error. So the two sources of error kind of group into two different areas. The first is what we call sampling bias. And so this is kind of relevant to what we talked about last time. There's two types of biases that come into sampling bias. What generally happens when people ask a question, especially when it's what we call a voluntary response, like the sort of thing where people call into a TV show, they're not even solicited, okay? We just ask people for their response. What often happens is you hear from people that have a vested interest or a very strong opinion about something. So if, for example, like you listen to the news, they always have these surveys where they ask these really controversial questions, like, should Hillary Clinton be tried for crimes or whatever, right? Who do you hear from? You hear from the people that really hate her, and you hear from the people who really like her. You hear from the fringes, right? What you don't hear is the 80% that are getting on with their life that really don't have much of an opinion one way or the other. So that's called response bias, when you're hearing from people that have very strong opinions. Non-response bias is the fact that you're not hearing generally from the majority of people who wouldn't really feel strongly one way or the other. So there's actually two types of bias going on here. You're overrepresenting a group of people, underrepresenting another. And this always happens to some degree, okay? The other type of bias is actually a little more subtle. So this is respondent bias. And what that means is what you want to find out, you're not getting. And that can happen for two reasons. The biggest reason is because people generally are not 100% truthful. So as a really simple example, back in the 1950s, they did this survey where they asked people, what do you read? Do you read Reader's Digest, which was kind of like the popular, well-cultured, magazine back then? Or do you read like some sort of like, pulpy tabloid, okay? So twice as many people said they read Reader's Digest back then as opposed to the tabloid. But when you look at the subscription rates, they're actually the opposite. Twice as many people subscribe to the tabloids as Reader's Digest. So, do the math. There's something wrong with that picture. So people lie over such simple things as like what they read. When you ask them things about their income, you ask them things about, oh, you know, sex, racial prejudices, stuff like that, you're going to definitely get very, very untruthful responses, okay? So we know this. Now, there are ways of actually dealing with this. There are very clever ways of getting around that, but you have to know a little bit about surveying. If we have some time, we'll go into this. It's very, very nice. But the other is sometimes a surveyor. Your tone of voice, what you look like, the way you phrase the question, even just asking questions are sometimes very difficult to do in a neutral way. When you're asking questions about the environment, it's very difficult to ask questions in such a way that they're purely neutral. If you ask people, do you care about the environment? You almost feel compelled to say yes. Very few people say, no, I don't care, the heck with it. They don't say that. If you preface a question with information, like recently, 489 scientists signed this document saying that we should stop global warming. Do you agree? If you start prefacing it with information, you're already kind of leading people to say a certain response. So it's very difficult, very often, to kind of word something neutral. And last but not least, we get to the experimental studies. Okay. And these can actually determine cause and effect. So here we're trying to show that X actually causes Y. And the way we do this is we start with a group of people. Usually it's medical experiments, but engineers do this also. And they split them up into two groups. Okay, one group gets a treatment. So like if you're testing, say, if Lipitor lowers blood pressure, right? These group of people get the Lipitor, these group of people don't. Why do we have a control group? I mean, we're losing half of our sample, right? Sample size is important. Why would we even want to have a control group? What do you think?
It helps measure normal versus the difference. Like,
well, why are these people normal? Why don't I just take their blood pressure before and after? Aren't they normal? What do you think?
Is that like a reference point, like something that always go back to?
But why can't we take their condition before we give them the drug as the reference point? Why do we need a whole other group for a reference before and after they take the drug? Anyone know?
Is it the placebo effect?
And what is a placebo effect? You're absolutely right.
Essentially, like if you give someone a drug and you're like, this is gonna make your blood pressure go down. You give someone a sugar pill and tell them the same thing. Sometimes the human body, just by positive thought or whatever, will actually cause itself when it thinks it's getting help from an outside source.
So everyone's heard of the placebo effect, right? It means that you give somebody a sugar pill, whatever, and they get better. Okay. Now you had a really good way of putting it. You said they either think it or whatever. The reality is we don't even know why the placebo effect works. You might think it's because you're paying attention to people, but you know what? It works on dogs also, okay? Which is really weird. The color of the pill actually has an effect. So these are things that nobody could anticipate. But the idea is that if I look at the difference between the change of blood pressure here, that's what you would see with the placebo effect versus the change of blood pressure here, and this difference is really big, then I might say that's due to the drug. That can't be accounted for by the placebo effect. Okay? Now, we do this thing also called randomization. So the idea is that when you're doing medical studies, and this is probably the biggest culprit, there's 1,000 different things that can affect blood pressure. Do you smoke? Do you drink? Are you overweight? Do you exercise? Right? Your genetics. There's a gazillion different factors. So what do we try to do? We try to make these two groups so that they're well balanced. For example, if I have 4 women, we'll make the women red and the guys green, okay? If I have 4 women and 4 men, what I'm going to do is I'm going to choose my group so that I have 2 women and 2 men in both groups, and it's balanced. We can't say that gender was an issue, right? And the way we choose them is we choose them randomly. So I do like that random number generator, right? I give the guys numbers 1 through 4. I pick 2 of the numbers randomly from 1 through 4, and those guys go in treatment group. Okay? And that way we try to balance out things. What do you think would be the issue? If this was actually a real medical study, this is the actual study, what do you think would be one issue here? Sample size is too small. And so notice this is a real issue because when you're trying to test something like blood pressure medicine, and there's a ton of different factors, you need a pretty big sample size to make sure that you balance out everything really well. And that's one of the reasons why, and God forbid, at some point you'll get some sort of ailment, right, condition, and you have to read about these things, and then you have to really be careful about the sample size. Because clinical trials are really expensive, it's hard to get big sample sizes, which is one of the reasons why drugs don't often work the way they say that they're supposed to work. Okay. So two things really quick I just want to point out that I think any educated person should know about this sort of stuff. How many people have heard this phrase, correlation does not imply causation? Anybody? No? Nobody? Yeah. What does that mean? You know?
Means just because two variables happen at the same time doesn't mean one variable causes the other.
Can you give me an example? That's absolutely right. So I'll give you an example. This is something that actually was in a newspaper. So the newspaper published this article that made the observation that as the number of firemen at a scene goes up, the amount of property damage goes up. Implying, ridiculously enough, that the firemen were somehow responsible for the property damage. This is serious. This is in the Sacramento Bee. What's really going on? Why are those two things correlated?
It's the fire department bigger.
Exactly, right? It makes sense. So there's actually a third variable that's causing both to increase. Okay, that's called a confounding variable or a lurking variable. So while this is true, okay, it's not totally true. So correlation alone cannot imply causation, but we can't actually get causation. We can get correlation. I'm sorry. We can get causation from studies involving correlation. So, for example, smoking and lung cancer. So scientists now say smoking causes lung cancer. We don't say there's a correlation. Can we do an experiment where we take 20 teenagers and make 10 smoke and don't have 10 smoke? That's unethical, right? Knowing that it could cause lung cancer. So we can't do that. Even though we don't have experimental trials, you can use observational studies with other facts to actually prove causation. So there's things called propensity scores and Bill's criteria and stuff like that. You actually can show causation, but you have to do a lot more work, okay? So correlation alone doesn't from a single study. And just emphasize again that, you know, whenever you're looking at experiments, you always have to be careful about these unknown unknowns. Things that we don't know, like the placebo effect. There's no rational explanation. No rational person designing an experiment would come up with a placebo effect. And we don't know that there aren't other things. So we always kind of have to have that in the back of our mind. Okay. So that's pretty much all for different types of studies. Any questions that we have about studies? Anything from the homework you came across? Everybody's good? Okay. So what I want to do now is I want to kind of dive into chapter 2, which is now about categorical variables. So remember last time we talked about different data types, right? We said there were categorical and quantitative variables. This is just a real quick refresher. How can I tell something is categorical? What do you think? Anyone remember?
It's categorized in things.
The values represent categories, right?
That aren't numbers.
They sometimes can be numbers, but the numbers really just represent kind of like categories or levels, right? Like pain and stuff like that. So these are where the values represent categories, right? Gender is kind of like a classic example. The values are male, females. Kind of like bins that we're putting people into, right? And what's a distinguishing feature of quantitative variables? They have what? Units. Exactly. So we're measuring the amount of something. The one counterexample is percentage, which the book actually says has units of percent. I'll go along with that, okay? But these are things that have units. Count data, physical measurements. Okay. So what we want to do is we want to talk about how do we summarize data. This is kind of an example of how you might think about this, okay? For example, if I want to describe to you what my sister looks like, There's a couple of different options. So first of all, I can take her picture and digitize it like there. And I can say, hey, here's a picture of her, what do you think? All right? And you would look at me like I'm nuts because we can't process a lot of information, especially numbers, right? So I make a table, but it really doesn't do any good. Too much information. So I can just show you a picture. Now you have a really good idea. But I might not have the picture available, or I might just want to describe it in words, right? So what do? Well, I'm going to take the main features of this plot, right, and I'm going to describe it. Maybe their skin color, hair color, eye color, etc. Okay. So this is how we're going to do data. We're going to make a table, kind of summarize all the information, right? Boil it down. This doesn't have, that file there doesn't have all the information, right? It's just like the intensities and the hues and the pixel, right? I've kind of taken reality and made it into a table. Then we're going to plot the table. Then we're going to describe the plot. And we're going to do that for both data types, okay? Same sort of principle. Oops. Okay. So what I want to do is I want to go to the data set that we were talking about, cars. And let's just take a look at this for a minute, okay? Okay, so if you don't have the data set loaded, just come on over here, modules. And this is the metadata. I'm going to download that. That's going to be the context, right? And this is the actual data set. We're going to download this, okay? So I want to look at the metadata for a minute. So the metadata says that there's 810, that's our sample size, 810 observations, there's 12 variables. This was data that a person collected from the Kelly Blue Book on a couple hundred 2005 used GM cars, all right? And they actually put this, so this woman's a very good statistician. She put this together to kind of help teach students statistics, okay? That was her motivation. And then it goes ahead and it tells you what the variables are, okay? So if we look at the who, let's answer some of the basic questions here, okay? So if we look at the who should be Shonda Cooper, right? She's the one that collected the data, right? What is the who? When we're doing the W's. What's that? Well, closer.
Vehicles. GM cars.
It's the guys that are in our sample, exactly. So the who are the 810, okay, cars we collect the data on. The who is always the sample. The why, these are the questions we have to answer. Who, what, and why. The why, well, there's actually two reasons. The one is why she put the data set together, which was she wanted you to kind of play around with data and learn. But we're going to find that we could use that data. How can you use data about cars? What could you do with it? Well, think about that for a second. Go ahead.
To rate them, like look at the car.
Kind of. So let's go more into. It's kind of hard to tell until we look at the data, right? So let's leave why blank. Let's look at the what. What are the what? This is referring to the variables, right? So these are the things that I'm taking data on. So what are my variables here? I got a lot. I got 12 variables, right? I'm going to make a little table, okay? We'll put the name of the variable here. Maybe its values, kind of what values it can take on. And let's look at its data type. Okay. And let's go ahead and do the quantitative first. So let's see, which ones here are quantitative? Which of these variables do you think? I'm sorry? Which ones? Go ahead.
Cylinders, liters, and doors.
Cylinders, liters, and doors. Okay, I agree with that. So cylinders, exactly. So there's a couple more. So cylinders is the number of cylinders, right? So this is what, 6, 4, 6, 8. That's definitely quantitative. Okay. Doors is a number of doors, right? Whatever, 4-door, 2-door, that's quantitative. What else did we say? Size was the size of the engine, right? Or what is it? Is it engine or size? I forget. Liters, thank you. Neither. Liters is the engine size, right? And of course, that's quantitative. Let's see, what else did we say was quantitative here? Got doors, cylinders, liters. Price and mileage, right? So price is in USD. That's quantitative. Mileage in miles. That's quantitative. Anything else we left out? Make, model. That looks good. I think we got them all. Okay. Those are all of our quantitative. All right. What about when I look at the table, I see something kind of interesting. If you look at the data, so let's go ahead and load this in and take a look. By the way, if you have questions with using StatCrunch, so even though I'm making a video of what we're doing now, okay, I'm going to post the video, so if you miss things, you can always go back and watch it. But if you have questions, now's a really good time to ask. Because what we're going to see is that the steps we go through, we're going to go through really kind of slow in the beginning. We're going to see that almost all the commands have the same basic type of stuff. So things that you clear up now are really going to help you down the road, okay? So don't feel weird about stopping class. I'm more than happy to answer your questions. So remember we found out before how to load in data, right? Gonna load that up. And I might kind of argue with you now, because if I look at, for example, sound and leather, I see 1 and 0. Aren't these numbers? Isn't that quantitative? Why?
It's yes and no.
You're not needing to like add or subtract these values or compare them against each other. It's just binaries of true and false.
Okay, so you can't do meaningful math, and the binary really means what? It means that I'm taking, if you look at, for example, leather, let's just look at leather as an example, okay? The values are 1 and 0, but there's a little key, right? So the 1 means that it has leather, and the 0 means that it doesn't. And so we sometimes call this an indicator variable, okay? Basically, or a dummy variable. It means that it indicates when something is present, and when it isn't, it's 0, okay? So this is definitely categorical. And there's a lot of them like that, right? Sound is like that. 1 and 0. What's the other one? There's one other that's like that. I'm sorry, what was it? Cruise, thank you. Yep, cruise is like that. Same sort of thing, right? Categorical. And then we have make, model, go ahead, trim, and type. Okay. And so this is kind of obvious, right? This is like Chevy, whatever, Saab, etc. The model is kind of like the SE, LE. Do I have that right? I sometimes mix them up. I'm sorry, type is like sedan. This is a sedan coupe. The trim is the SE, LE, whatever, right? And then this is the model of car within that make. All right? All categorical now, right? Okay. So notice that there's a lot of work that goes into, you have to kind of decipher what the data set is saying before you can do anything. Now, looking at all those variables, having all of that, how do you think we could use this data set? How do you think that you would use it? Yeah?
Like to search for a car.
I'm sorry?
Like to narrow your results to search for a car.
But what am I going to be searching for? Like, what would I be narrowing it down? I got 12 variables, right? Which one would really be of interest to me? I don't know about you, but when I look at a car, there's one thing that's really important. What is that? price. Okay, so we definitely want to say something about price. How could we use this data set maybe? What could we do?
Between makes.
We could sort, yeah, that's true, and we could see like what's in our price range, right? But how else might we want to do it? Maybe I want to predict price, right? I might want to see how these different factors affect price. Okay? So maybe my why here is that I want to understand the relationship. How do these different variables affect price? In other words, what happens when you add leather? How much does the price change, right? So if we just focus on these categorical variables, we have what? 1, 2, 3, 4, 5, 6, 7 categorical variables. What do you think are the most important in determining price? And which ones are the least important?
Probably make.
I think make is extremely important, right? So maybe make and model, right? These might be our primaries. Which ones would probably have the least influence, do you think? Like, do you think leather's as important as make? That's like an accessory, right? So these are probably going to be secondary. This one maybe not so obvious, okay? So I've had one student that knows a lot about car prices. He tells me that this is really tightly linked to price. So let's kind of put a question mark, okay? So we're going to see. And some of these things kind of interact. They affect each other. So we're going to do an analysis and kind of sort through this, all right? So any questions on the data set, the variables? Okay. So let's start doing some plotting. So what I want to do first, in order to get there, I have to make a table first. Okay, I'm going to make my table. So we're going to make a table. We're going to plot the table. And when you think about it, categorical variables, they're really simple to work with. There's only one thing you can do with categorical variables. You can just count the number in each category, right? There's nothing else you can do. I can count the number of ones that are in the leather column, right? Count the number of zeros, but I can't do anything else. Can't take averages. Can't really do arithmetic, like we were saying, okay? So categorical variables are really simple. So we're just going to make a table of the counts, then we're going to plot those counts and describe the plot. Okay, so first let's go ahead and make a table. This is called a frequency table. And so what we're going to do is we're going to go into StatCrunch, and at the top menu, you click on Stat. It'll bring down this menu. I'll cut it off. There's a ton of stuff down here. We'll just click table, and then we'll click frequency. So Stat, tables, frequency. And there we go. Now, one of the things about StatCrunch that I like is the fact that whenever you click a command, you always get this dialog box that opens up. It has the same form. The first thing you have to tell StatCrunch is what variables do you want to work on, okay? So here's what we're going to do. You're going to go ahead and you're going to click on make. So since we think make is really important, let's look at make first, okay? I'm going to go ahead, I'm going to click on make, and when I click on the left-hand column, it's going to populate the right-hand column, all right? Then I have to say what sort of table I want to make. And you notice there's actually 3 ways that we can kind of quantitate how much of the sample is in each category. The first is I can give you the counts. The second is I can give you the fraction, right? The fraction that's in that category. So I take the number in the category divided by the total number in the data set, okay? And that's called a proportion. That word is really important. We're going to come back to that a lot, okay? So this is the fraction of the sample that's in that category. But we don't think in terms of proportions. You never hear the weatherman say there's a 0.3%, 0.3 chance of rain today. Nobody speaks in terms of decimals. We all use percentages. So we're going to generally work with percentages, okay? So we're going to go ahead and choose percentages. You can choose all three if you want, just to see what they're like. There's kind of one exception to that rule. So generally, we either choose counts, we either choose frequency or percentages. A little bit depends on the sample size. When the sample size is really small, we choose frequency. The reason why is because there's not enough data values to really estimate the percentage well. So if I only had 8 data values, I wouldn't plot the percentage, okay? Because the percentage changes by 0.125, depending on whether or not, the counts change by 1. When I have a really large sample size, 800 is a very big sample size, I'm going to use percentages, okay? So let's go ahead and do that. And the last thing we're going to do is we're going to store it in a table, okay? And that's going to put a table inside of StatCrunch. So here we go. Make. And one thing about choosing multiple things in a menu, if you click on one and hold Control, you can choose multiple ones, okay? So I'm going to click on that, hold Control, and then you can do this. Store in a data table. And when you hit compute, what'll happen is it'll actually make a table. So you can see over here now there's this table, okay, right here. Let's see how everyone's doing. Make sure we're kind of on the same page. Okay, looks good. Yeah, so you didn't do it in a table, that's fine. As long as you can see it. Looks good, looks good. Okay. Good, good. Yeah.
It's not allowing me to.
Yeah. What's that? Hold shift. Yeah, right. Control and then yeah. So if you have an Apple, it's going to be different than if you get that. Okay. All right. So what can we tell from this? Kind of boiled down the data a little bit. I mean, before we had to look at 801 rows and make sense of that. Nobody can do that unless you're like a savant, right? No normal human being can do that. Now I can kind of see a little more what's going on. How would you describe that? How would you describe those results? What kind of stands out?
Frequency.
And so I'm going to look just at the percentages. Okay, so I see that like 40% were Chevy. Okay, and then see, there's the next one is like Pontiac's like 18, Saab is 14%. Okay, so I kind of get an idea. So Chevy by far is the most common occurrence. Anything strike you as strange? Why is Saab in such a high percentage? I mean, 14% of the cars are not Saabs, but why are they Saabs here? Did the person do a bad job of sampling? Are they biased for Saabs? Saabs in there? What do you think? So this is kind of a little tricky. Remember, we got this from GM cars. That's why you don't see Fords, right? So this is among GM cars. So we're supposed to believe probably that Saabs maybe constitute 14% of GM cars. Something I didn't know. But things that kind of strike out, things that kind of strike you and stick out, okay? So this is our frequency table. That's all we have to do.
But doesn't that go by the favoritism of the customer?
What's that?
It goes by the favoritism of the customer.
We don't, yeah, here's the thing. We don't know how that person picked the 801. So notice that I didn't answer the question how, right? So she picked it from some sort of database, the Kelly Blue Book, but we don't know how she picked it. So maybe she was a little biased. Maybe she was interested in stocks. Who knows? So we don't know 100%. But the fact that it's so populated doesn't really concern us too much because we are kind of restricting ourselves to GM cars. But you're right, we don't know how to pick it. All right. So, okay. So,
speaking, all these numbers could be possibly incorrect.
it depends on how she sampled. If she really sampled randomly, then they're probably really good estimates. If she didn't sample randomly, we don't know. And in fact, this is a really good point because we had a data set that I was going to use. If any of you guys downloaded the notes from yesterday, you'll see there's a different data set I have. There's a reason why I changed data sets because the author didn't give context. for that data set. And I actually contacted him. I saw him over the week when I was at that workshop. And I said, hey, you're telling everybody you can't use a data set unless you can answer these questions, and we can't answer these questions. So, tell me what these things are. And he gave me another data set, and it turned out it looked really bad. It looked really fake. So I didn't use that. I don't think that he sampled randomly. But you're right. How we get the data is really important. Okay. Okay. So let's go ahead and make a plot now. So making a plot's pretty easy. We always go to the graph tab. We go to the main menu, hit graph. Again, you'll get this huge list. And we're going to make a bar plot. In other words, we're going to make a plot that kind of looks like this. So we're going to take, let me use this here. So the idea is that we have our table here, right? So we said what Chevy was about 40%, right? What was the next highest? Pontiac, and what was that? 18%?
Just over 18.6.
Okay, we won't split hairs. What was next?
So at 14.
Saab was 14. Okay, and we'll kind of just round it off. Okay, and then what was next? And then last was Saturn, right? And that was like 8 and 7-ish things. Okay. So here's what we want to do. We're going to put the make on the x-axis. So notice the x-axis doesn't mean anything. Okay, it's just a placeholder for the different categories, right? So here's going to be Chevy. Okay, and then maybe Pontiac. ... Saturn. So on the x-axis, we're going to have the make, right? And on the y-axis, what are we going to have? We're going to have percentages, right? And this is what a bar plot is, right? So this will be around 40%. Pontiac will be around 18%, and so on. Okay? And so the name sounds like it is. It's a plot where the heights are bars, okay? So let's go ahead and try that. So I'm going to go to Graph, Bar Plot with Data. And notice now I have the same sort of kind of like menu, right? I have to tell StatCrunch what variable I'm going to select make. And when you go to this under type, you'll see there's a couple of options. There's frequency, proportions, and percentages. I'm going to click on percentage. This puts the percentage above the bars. That's really nice when people are looking at your graphs. They want to try to interpret it, what the values are. And then finally, we're going to fill out the axis labels. Okay? Let's go ahead and try that. Okay, so I'm going to do make. And I'm going to do percent. Value above bar. Okay. And then I'm going to fill out the labels. So this is car make, or make of car. This is percentage. And then I'm just going to say distribution of car makes. Okay? So a really good thing to do when you're making a plot, just a general word of advice, the plot should always be really clear. In other words, a person should be able to look at a plot, not have to go back and look at your data, not have to go back and read your report. The plot should be self-explanatory, okay? And I'm going to tell you this because, especially in business, if you're dealing with the government, for example, and I'm not trying to be nasty here, but when you're dealing with the government and you're presenting things to higher ups, which happens a lot with contractors, you work with Boeing or something like that, okay? The people that you're talking to, generals and stuff like that, and I know this because I worked for AFOSR, I did research with the Air Force. They're really good at what they do, They're not good at technical stuff usually. They don't know technical stuff. That's your field. And if you go writing plots that have a lot of jargon and it's really tough to understand, guess what? They just drop off, okay? So you want to really gear it so it's very transparent. They call these killer plots. They're plots that you can see what's going on real quick and you can understand what's going on. Good labels, good titles really help towards making a good plot, okay? So we go ahead and click on that, and now you can see we have our plot. All right. Now, there's one thing about this plot that's not too nice. It's a little hard to read. What I would really like is I'd like the one that had the highest percentage to go first, and then have them kind of go down in descending order, right? So you can do that in StatCrunch. If you want to change how you did the plot, you click on Options, okay? And you'll see this thing called Edit. Go ahead and click on that. And there's this thing here. It's not obvious what it means, but this order by says, how do you want to order the categories, okay? So I'm going to tell StatCrunch to order it in counts descending, meaning it's going to start with the category that has the highest counts and go down, all right? And when I do that and click Compute, notice what happens. Okay. Now you get a really clear picture, right? You look at that and you can really see what's going on, all right? So, you're in the elevator with your boss. Gives you the data set. Maybe he wants you to predict the price card for him, right? Who knows? And he says, hey, what did you find out about the makes from that car file? How would you describe this plot? What do you think? How would you describe it?
Well,
Go ahead. Take a shot. So here's the thing. What you're really looking at is what catches your eye. What catches your eye in this plot? Right. So the one that we definitely want to report is the one that occurs most, right? We call that the mode, okay? So how do we describe this plot? We have our table, our plot, and here's our description. We always report the mode. In other words, the one that occurs the most. So this is the most commonly occurring category.
but shouldn't I report both,
I'm sorry?
the maximum and minimum?
So this, okay, so we'll get that in a minute, okay? This most commonly occurring category. But yeah, you're right, both can be important. And what we want to do is we want to report the actual category, which in this case is Chevy. And we want to report the percentage. We want to report the frequency or the amount, right? So in this case, I'm going to report the percentage, which is about 40%. Okay. So I tell my boss the mode is Chevy. It was the most commonly occurring, roughly at 40%. Okay. Now, how do we describe the rest? Okay. So that's kind of subjective. It depends on the data set. The way I might do it is I might kind of group things. I might say, Saab and Pontiac were roughly about 15%. We're not trying to put a really fine point on this, okay? And then I might say something like, Buick and Cadillac were roughly 10%, Saturn around 8%. Or I might even group all of these, really. I might say, Buick, Cadillac, and Saturn were all around 10%. So you want to kind of describe what other features you see. And usually we kind of group things, all right?
That's how we usually did it anyway. We go with the most, and then the least, and then in between, whatever is most favorable to the budget.
So say this again now. So you
So we go with the
most
highest percentage, and then the lowest percentage, and then in the end, we go with the most favorable for the budget.
So like what sort of budget are you thinking about?
Considering if we're buying supplies, or equipment, or whatever the case may be, some equipment might be the best to be used in the field, but the case comes down to what the budget is. So you gotta go with most efficient, but in the same time, most effective for the budget.
Okay.
So you gotta pick the most advanced technologically, but in the same time, not the most expensive, so that way you can preserve on the budget.
So I like this example because it points out a really important fact. and this is something that people get kind of stuck over sometimes. We have guidelines in statistics. Like, we definitely report the mode. That's unequivocal, right? But what else do we report? So one of the things that happens is people take guidelines and they use them as rules. Statistics is a lot like golf. Okay? Not in the sense that it's frustrating, okay? But no, not that way. But it's like, for example, if you're playing a game of golf and you hit your ball in the rough near the green, here's what you don't do. You don't take out a device that measures the distance from you to the pin and then go to a chart and say, oh, I'm 70 yards away, I should use an 8-iron, right? You don't do that. You know, you look at the ball, you see where it's lying, you see how thick the grass is, you see what's in front of you. Do you have to clear a shrub? Well, then you might want to hit a wedge hard rather than a 9-iron, right? So you have tools in hand. You can do it different ways. You can group things, you can report police also, but it really depends upon your situation. And it isn't that it's ambiguous or vague, okay? Or something like that. It's because it really depends upon what it is you're studying, what your needs are. So we're going to come across a lot of these rules, and people very often, they want really simple answers. Like, when a sample size is over 30, do this. Try to kind of, liberate your mind. Don't think of them as hard and fast rules. Think about what you're doing. That's what really matters. Why don't we take a little break, and we'll come back and start on 2 variables, okay? Okay. So any questions on the one variable category? Everyone's good? Okay. So I want to start to look at two variables. We probably won't get finished today, but make a pretty good stab at it. I'll just mention really quick, okay, a couple of things you can try to do, and I kind of encourage you to do this, is you can also make the plot directly from the table. So when you go to plot, rather than say with data, you'll say with summary, okay? It's useful because sometimes StatCrunch will give you summarized data. Let me just show you really quick, okay, just so you're aware of this if you come across this. So, for example, I can go back and make this same plot, and here's how I do it. Under graph bar plot, I'm going to say with summary now. That's going to plot it from the table. Okay, so when you click here, it's going to ask you where are your categories, and I'm going to use this table right here, okay, on the right. So I'm going to choose make. I'm going to get rid of this. I'm going to choose make. And then the counts. So now it's asking me for the counts in the table, and I'm going to use the percentage, okay? Percentage of total. That's going to be my counts. All right. So I'm using this far column right here, okay? And then you can go ahead and you can do all the descending and all that stuff. I won't do it. But when you hit compute, hold on. Something happened there.
Was the wrong make used?
Yeah, thank you. Yeah, that's right.
Mistake earlier with the other ones. That's why.
You got me. Okay, there you go. That looks better. All right, thank you. So you can make a plot from the table also. Like you said, it makes a difference which make you use, okay? So some of the homework problems will ask you to do that. One thing I'm not going to do is I'm not going to dwell on pie charts. I will tell you, people in business love pie charts. Too much so. I'm not a fan of pie charts. The reason why I don't like pie charts a lot is because generally when you look at categorical variables, you're not interested in just one. I mean, we don't actually care about make in and of itself. We care about how make goes with other variable associations. When you have two categorical variables, pie charts don't work so well. If you figure out a way to do that, let me know, and we'll write a paper. But I haven't seen anyone that really can look at two categorical variables together with a pie chart. I think it gets a little busy. Okay. So that's why we're not going to do a lot with those. But go ahead and play around with those. Okay, so I want to talk about two categorical variables now. So what we want to do is we want to look at how often two categories occur for different variables. And so let me just kind of pose this question. What if we look at make and letter? This will be my first categorical variable. Is it okay if I use var for categorical variable? Everyone knows what that is, okay? That's my first categorical variable, and my second categorical variable will be leather. And what I want to look for is I want to see if there's an association. In other words, do certain makes have a higher percentage of vehicles that have leather interiors? Okay? So how do we do that? So now we're going to make a different type of table. We're going to make what's called a contingency table. Okay, it's going to be like a little matrix. Contingent means dependent on. Like if you're in ROTC, for example, they say that your continued enrollment in ROTC is contingent upon you having a certain GPA, right? Well, that's what we're looking for here. We're looking for a dependency, okay? So here's how we're going to do this. We're going to make one of these categorical variables the column variable. And I'm going to choose make here. And we're going to have a row variable, which is leather. So what I'm going to do is I'm going to write the values that leather can have. Leather can have values of 1 or 0, right? Make can have values of, Chevy, Pontiac, and I won't write them all, okay? Down to Saturn. And so we're going to make a table. The table's going to count how many Chevys have leather, right? How many Chevys don't have leather? how many Pontiacs have leather, how many Pontiacs don't have leather, and so on. But I'm going to do something a little different also. I'm going to compute the row percentages and the column percentages. And what I'm generally going to be interested in this case, is the column percentage, right? I'm going to know, I'm really going to be interested in what, if I just restrict myself to Chevys, this column, I want to know what percentage of Chevys have leather interiors and which don't, okay? That's what I'm going to do. And so we're going to be looking for this association here. So here's how we do it. Start off kind of the same way. I'm going to go to graph. I'm going to go to tables. I want to make a table first. But now instead of frequency, which is for one, the first one's for one variable, the second one's for two variables. I'm going to click on contingency with data. Okay? So let's go ahead and give that a try. So I'm going to say stat, tables, choose the second one for two variables, and with data. Okay. And now it's going to ask me, what do you want for your row and your column? And it's kind of arbitrary. But if you think about it, we have a lot of makes, okay? So if you make the row variable makes, you're going to have a table that goes like this, that's long. I like a table that's wider. For me personally, it's easier to read. So I'm going to choose my row variable to be leather. And here we are. And the column variable to be make.
Second make.
Not this make, yeah. The bottom one.
Make sure I got the right one. I want the first one here. Because I don't want the table, right? The table is for the one variable. I want to choose the first make, okay? So be careful. And then I want to go ahead and I want to compute actually all of these. I'm just going to drag, or you can click on one and hold control. Okay. And I'm not going to worry about these things right now. We're going to come back to these other parts of the table later. And just hit compute. And there's my contingency table. Very busy. Okay? So let's take a look at this and make sense of this. If I look at the Buick, okay, under the Buick and 0, if I look at where Buick and 0 intersect, what does that 45 tell me? What does that mean?
Or don't have a leather.
Right. So it says we have 45 Buicks that don't have leather. So this must mean that 35 Buicks have leather, right? What does the 20.27 mean? How do I interpret that? So that the first column, the first row, what are those numbers?
That's the
Row percent.
And so if you had to tell me in everyday ordinary language, how would you express that? What does that mean? What do you think?
No, my idea is no.
No, go ahead. Give it
I
a
was
shot.
going to say it could have been a percentage of the row, but then I looked at it. Oh, yeah, percentage of the row.
It is, but just tell me in everyday language. You're right, it is the row percentage, but what does that mean? What is that? So kind of interpret what that 20% means.
20% of Buicks have cloth or don't have leather.
Yeah.
20% of the total cars
Yeah.
It's 20%.
are Buick and they
That's
don't
what it
have
is.
leather.
No.
Okay.
Anybody else? It takes a little while. What do you think?
20% of the total cars that don't have leather are
Ding, 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 ding. That's what this row is, right? So when I'm at this row, I'm restricting myself to cars that don't have leather. 20% of this. How do we know that she's right? Well, one of the ways we know is that we look at that total, it's 100%, right? And if you add up all of those numbers in that first row there, you'll find out that they add to 100%. Okay. So what the row percentage means is that you're restricting yourself to that value in that row, and then I'm looking at what percentage each of those categories in the column that have. Okay. Okay. So what if we look at the 56.25? So now, what does the 56.25 mean?
That's the Buick.
Yes, but what about them? But what about them now? So it's saying what?
It's saying that percentage of Buicks don't have leather.
Right. So now I'm restricting myself. This is the column percentage. I'm restricting myself to the column of Buicks, right? I'm saying of all the Buicks, 56% have leather, roughly 44% don't. Good. And the last is a total percentage, and we're generally not interested in that. Okay. So that's saying that 4.35% of all the cars are Buicks and have leather. But I'm usually not interested in that, okay? All right. So those other two percentages that you wrestle a little bit with, those are called conditional probabilities. Okay, it's conditioned upon knowing something. It's conditioned upon knowing that the car doesn't have leather. It's conditioned upon knowing the car is a Buick. All right? Okay, good. Questions about that? Takes a little while to kind of deal with that, all right? So last thing I want to do, let's go ahead and plot them, okay? I want to show you how to do the plot, and then we'll call it a day. So the way we're going to plot this is we're going to go and click on, we've already done this part. I'm going to click on Graph, Bar Plot with Data. It's going to start off the same as before, okay? So we'll say Graph, Bar Plot with Data. And here's what I want to do. And how you plot this depends on what you're interested in. What I'm interested in, myself, what I'm interested in is the percentage of each make that's leather. So what I want to do is I want to make a plot that looks like this. This is going to be the make. So this will be Chevy, Cadillac, whatever, okay? And then within each of the makes, I want to plot the percentage that has leather and doesn't have leather. So for Chevy, what did we say? It was 56%, right? That had leather, and 44% didn't. Okay? So I want to group things by the make. So let me kind of show you how to do this. Maybe not so obvious.
Why don't we make leather and also, why would we add mileage?
So right now, we just want to look at the relationship between make and leather. But there's a lot of other relationships we can look at. You're right. And if we look at mileage, that's quantitative. So that's going to take us in a whole other direction. But we're going to come back to that. I mean, ultimately, we want to understand about mileage, right? But we're going to come back to that. So I'm going to click mileage here. Let me just kind of step you through this. And I'm going to click leather here. I'm grouping by leather. Okay, and then I'm going to go ahead and I'm going to click percentage within each category, value above bars. So kind of follow along here. Mileage, group by leather, and be careful. Okay. And I'm going to say percentage within category. Okay, so in other words, within this category of Chevy, I want to give the percentage.
I shouldn't use select make.
Yeah, it should
instead
be
of mileage.
You have mileage selected.
Oh, is that what you were saying?
That's what I'm saying.
I'm sorry. I was wondering.
I mean, I get the mileage has to do with other variables, but I'm not even there yet.
I'm sorry. I was wondering what you were talking about. I apologize. Thank you. Okay, here order doesn't make any difference. Value above bar. I'm going to fill this in later. Okay, we'll come back to this. I just want to make the plot for now. Okay. So now it makes a little. Oh, and I want to click value above bars, which I don't think took for all of them. Kind of interesting. Not sure why that happened. Huh. I'm wondering why the percentages aren't above these bars. I have it for Cadillac and Pontiac. That should be fine. Make. I think I jinxed myself when I did the mileage. Okay. In any case, this does tell you, if you hover over the bars, it'll actually tell you the percentage. I can kind of see from here, right? This is a little over 40. This is, over 50%. Okay. Notice Cadillac, all leather. Okay. So Cadillac and Chevrolet have mostly leather. All right. And you can see when you get down to Saturn, not as much Buick and Saturn, which is kind of what we expect, right? You see kind of like an equal mix. Okay. All right, we'll come back to this. We'll kind of review this quickly and finish up two variables, and I think we're pretty much done.
I think it's selected Pontiac because you only highlighted Pontiac. That's why.
I'm sorry?
You only highlighted Pontiac, and that's why it only percentage.
So hold on. So step me through this. So when I did this, whoops.
When you go select.
So why do you think it just did Pontiac and Cadillac?
Prior-
I'm sorry?
Prior to this election, before you start the bar itself, so reformat, like do it all over again.
Yeah, let me just try it all over again really quick. Let's try it. Okay, so pie plot with data, make group by leather. Let's just see. And above bar.
There we go.
And there we go. So just try it over again. I'm not sure what I did the first time. I'm not 100% sure. I'm sorry?
Because when you selected mileage.
Oh! I know what I did. I didn't do percent within category. I'll tell you, we'll come back to this. Play with it. If you follow the instructions, you'll get it. We'll come back to this, okay? We'll do it again. I know what I did. I was trying to be Russian, and I should have been American. You know why? Last 4 letters of American, or I can't. Well, don't be Russian. All right. Thanks a lot.